Dry. Don't repeat yourself. Let's figure out what does it actually mean. In simple terms, don't write code that does the same thing twice. It doesn't mean that you must only ever write one loop within all of your code. But in the same time, you shouldn't rewrite business or core logic multiple times by hand. Remember that every piece of knowledge must have a single, clear and authoritative representation within a system. Common scenarios that need dry. A significant amount of duplication happens while designing classes. We end up implementing the same business logic in multiple portions of the code. A simple solution is to abstract the common functionality and only implement the parts that differ. In the following code, we abstract the common functionality get salary. Another common example is explaining the logic of code in comments. Writing more readable code on all code often eliminates the need to write comments. In the following code, we can use a more meaningful variable name. This would eliminate the need to add a comment that explains the necessity of the variable. Another common example of duplication happens while storing data. We end up creating unnecessary attributes in our tables. We can often derive these attributes from others as they mutually dependent. In the following example, age is a redundant attribute that it can be derived from database. The problem now is that change in one attribute requires a change in another. Here we come to another problem. The problems of the application. The root cause of all these problems is the creation of duplicate representations of knowledge. This knowledge is mutable, in other words, subject to change. And as soon as it changes, we need to change all its representations. Making such a change requires due diligence. In contrast, not making the changes properly will lead to contradictory representations of the same knowledge. An example. Both functions implement fetching a user which requires at least some knowledge about API endpoint and what options have to be set to successfully retrieve a user from the API. Why is it important? As you have seen above, implementing basically the same logic twice also yields to places to check if something ever changes. Take the user API for example. What if the endpoint changes? Right, you also have to change to occurrences in your code. But what if you forget one occurrence? Well, hopefully you have tests covering that. But this leads to another issue. You also have to test the same things twice for two different use cases. The issue with multiple places where the same things happen. You are, however, still left with multiple places you could forget to change. And this is exactly one of the reasons you shouldn't repeat yourself. It isn't easy to spot all occurrences of repeated code, and if that code has a special meaning, it's a breeding ground for bugs. Fixing the issue. To fix the issue, you can abstract away how you fetch a user from your API by placing it within its own function. Whenever fetching user changes, you only have to adjust one specific piece of code and only one specific set of tests. one function which does exactly what it said it does, getting a user and returning it whenever you need a user within your code base. Import that function and use it. What are some common reasons for these types of the applications? Someone made a mistake during design, and that mistake propagated to the later stages of development. It's possible to salvage this problem without significant cost if you detect them early enough. Sometimes projects have strict deadlines that put pressure on the developer. Soon it becomes more tempting to take shortcuts instead of writing clean code. There might be unintended applications where developers don't even realize they are duplicating information. This is more common in large organizations where entire functionality might be duplicated. The most common reason for this is a lack of collaboration between teams. Sometimes the environment demands code duplication, and the developers needs to show ingenuity to avoid such duplication. Approaches to resolving duplication by try. Try is only a principle. Developers or managers of the project are free to choose how they implement the principle. They implement the implementations might be diverse depending on their use cases. Let's briefly discuss the three most common methods. Abstractions. This is commonly the case for designing classes. When multiple classes share some common business logic, we simply abstract the logic into a superclass, which each class then inherits. Standard object-oriented programming (OOP) has many practices that encourage the try principle for writing readable, reusable, and maintainable code. Furthermore, there are alternatives like composition that solve for the the limitations of using inheritance and give programmers more flexibility. Automation. This is the case for project warrants of developers. Teams should be cross-functional to ensure active communication between developers. Managers should encourage such communication so developers never end up repeating completed work and can discuss their usual problems. Removing duplications that rising isn't enough. Instead, it must be an active process. Without proper system and oversight, this problem will persist and continue plague the organization. Normalization. This is the case for designing databases. Duplications are common in many data representations. However, this creates redundant data which is harder to maintain. Instead, extract the duplicates into a separate entity. The source then references this entity. Overuse of drive. Every line of code written doesn't have to be unique. Developers sometimes have fear of rework and waits and perceive this as the epitome of unproductive behavior. But the overuse of dry actually stops us from writing clean code. Every principle needs to be applied depending on the context. Sometimes code duplication suits the environment, removing that might introduce unnecessary upfront coupling or complexity into the system. In such situation, living with a bit of duplication might not be the worst thing. Uh, Premature optimization is also a common issue with Revue developers. Uh, as a general rule, developers should avoid applying generalizations to functionality before it's repeated. More real and immediate problems take precedence, and it's paramount that we solve those problems first. Conclusion. The dry principle is a pretty great way to reduce repetition and also complexity within your code. Take it this way. Better be lazy and write stuff once than to repeat yourself over and over again while wasting precious time. It's all.